Hello and welcome to the solution guide for Ciphered Japanese Sums by myself, the pedaling pianist. Now, as you can see, there are a lot of rules. If you're watching this video, there's a good chance you're probably quite familiar with the rules. So just in the interest of speed, I'm going to apologise to anyone who has no idea what's going on. And rather than reading out all the rules, I'm just going to show you an example of a completed grid, which is helpfully provided by the bookworm, the original author of the Japanese Sums puzzles. Thank you very much for making such helpful examples. So this is an example of a completed grid. If we look over here on the left, what the solver has to do is find a 5 by 5 grid and then do chaos construction on that, which means it's a Latin square. You can't repeat any of the digits from 1 to 5 in a row or column. But you must also find 5 regions, which must also have the digits 1 to 5 in exactly once each. If you look at this top row, what you can see is that there is a region that has 2, 1, 3, and 5, and then it sticks into row 2 as well. But then at the end of this row, we have a different region that has a 4 in it. So within the big grid, you then write a normal Japanese sums clue, well, two clues, an 11 here and a 4 here. That represents 11. 11 represents the run of digits in this region, 2, 1, 3, and 5, sum to 11, and then 4, which is on the right hand side of the 11, represents the region on the right hand side, which is just a 4, so 4 is the sum of 4. You could put the 11 here and the 4 here, or the 11 here and the 4 here, as long as the clues are attached to the grid and the 11 is on the left, because within the grid, the run of cells that sums to 11 is on the left. So that's one thing that you have to do. But the clues that you get are not these internal clues. You get these external clues. These clues are the sums of contiguous runs of even and odd digits in the row, or not even just digits, but numbers, because it includes the the internal Japanese sums clues as well. So you can see here in this row we've got 11, which is odd, 4 and 2 are even, 1, 3 and 5 are odd, and 4 is even. So if we take those strings of digits, we've got sums of 11, 6, 9, and 4. So we get these clues, 11, 6, 9, and 4. But it doesn't stop there, because what then happens to the clues, or what the setter then does to the clues, is arranges them in ascending order, read from left to right, or in this case from top to bottom. So this would be 4, 6, 9, 11, and then we divide all of the clues by 4 and take the remainder. So 4 divided by 4 would have remainder 0. 6 divided by 4 would have remainder 2, 9 divided by 4 would have remainder 1, and 11 divided by 4 would have remainder 3. And that gives these clues 0, 2, 1, and 3. So this is what you're actually presented with when you're solving this puzzle. You get shown 0, 2, 1, 3, and you have to deduce eventually, by using all of the other clues and all of that, that actually it's not 0, 2, 1, 3, it's 11, 6, 9, 4, and we use that to work out the internal implications of that. So this is the finished grid. I didn't even stop there, because obviously over here on the right we've got lots of zeros, ones, twos, and threes as our clues, but I replaced 0, 1, 2, and 3 with A, B, C, and D, so you have to work out which letter represents which of the numbers from 0 to 3. So I've ciphered it on another layer. So yes, my puzzle is rather complicated. The good news is that instead of having to find a 5 by 5 grid in the middle of our big grid, we only need to find a 3 by 3 grid and do 3 by 3 Sudoku on it. Well, chaos construction. So every row, column, and region which are to be found must contain the digits 1 to 3 once each. And that's hopefully an adequate explanation of the rules. So let's get on with the solution. And before we even look at any of these clues, let's draw an example grid, a 3x3 grid, and have a think about the possible arrangements of our three regions. Now, there are two things that we could do. We could either have a vertical stripe, at least one vertical stripe, or we could have at least one horizontal stripe. Every arrangement of three cell regions, and they are orthogonally connected regions in case that's not clear from the example. Every arrangement of those includes either at least one horizontal stripe or at least one vertical stripe. Once you've got one vertical stripe, you can then either make two more vertical stripes, or we could have L shapes like this, or perhaps like this. So there's lots of different options, but they all fall under the category having at least one vertical stripe. We could move the vertical stripe over to this side and do whatever we like with these six cells, but that's one kind of arrangement, the vertical stripe arrangement. The other option is, of course, a horizontal stripe, and then we can do what we like with those cells around there. However, there is immediately a problem with this, because however you arrange the three regions with at least one horizontal stripe, you will always get three different regions in this middle column. We've got green, pink, and yellow here. If we made the yellow this way round and the pink this way round, then, or purple, whatever you want to call it, we would still get three different regions in here. And I've deliberately made this grid a 6x5 grid, so that it's impossible straight away to have any horizontal regions, because then we don't have enough space to put in the internal Japanese sums clues for the middle column. So this is not the arrangement we have. We must have at least one vertical region, either that side or that side, and then something else happening in the other six cells. Alright, so let's bank that information and come back to it later. The next thing we can do is have a look at this middle row. Now, we cannot make the grid, the 3x3 grid that we're looking for, high enough or low enough that it avoids this middle row. It must intersect with this middle row. So in this middle row, we are expecting to see the digits 1, 2, and 3 within the Sudoku grid, and also Japanese sums clues outside the Sudoku grid that sum to 1 plus 2 plus 3, because they will be describing basically the sum of the digits 1, 2, and 3 in some kind of arrangement. So 1 plus 2 plus 3 doubled is 12. So A mod 4 plus A mod 4 must equal 0 mod 4, because 12 is 0 mod 4. And that must mean, therefore, that A is even. It could be 2 mod 4 plus 2 mod 4, or it could be 0 mod 4 plus 0 mod 4. But if we tried 1 mod 4 doubled or 3 mod 4 doubled, we would end up with 2 mod 4, and 12 is not 2 mod 4. So A is even, is what we can conclude from that. But that's pretty much all we can conclude from that clue on its own. But let's look at A, B. If we know that A plus A equals 0 mod 4, A plus B, given that B is not A, by the rules of ciphering, A plus B cannot equal 0 mod 4, and therefore this cannot be a column that has the grid in it and Japanese sums clues that sum to 6. So the grid does not come to this column. So we can immediately grey out all of this. Now, the next question is probably the hardest step of the puzzle. And I think there are a few different ways of thinking of it and kind of approaching it, but they're all quite tricky. So, yes, strap in, but the rest hopefully should be okay after this. Maybe you'll see a way of seeing this that makes it a little bit easier. The question is, can this row not include any of the grid? If it doesn't, let's say the grid is down here. Let's say we've got our vertical stripe, which we've proven there must be. We don't know which side, but we must have a vertical stripe. And then we don't know about the rest. Let's say it's two L shapes like this. Now, BCC would be saying that, well, these would be the only active cells in the row. These wouldn't be Japanese sums clues. They wouldn't have anything in them. So these would be the only active cells. The fact that we've got 3 different clues here says that we've got a run of even or odd, a run of the opposite parity, and a run of the original parity. So, and because we know that there must be a vertical stripe on the side, then 6 must be one of those. The 6 must also be the highest of those. Well, in fact, actually, we don't even need that anymore, because we then either get 3 vertical stripes, which is clearly a problem because this would just be 666, and we would expect a single clue here representing 2 mod 4 because 18 is 2 mod 4, or we get these 2 clues, which would necessarily be, well, would they? Yes, these would necessarily be referring to. Sorry, I just doubted myself for a second because I haven't considered the grid being down here. But let's just do it like this as the example. Oh no, that makes no sense anyway because then the 6 wouldn't be attached to the grid. Okay, forget that. My momentary doubting of myself was needless. So just here, these two, well, this one would be referring to this string of digits, and this clue would be referring to this digit, and together those 3 digits will sum to 6. So these two sum to 6, so they must be the same parity, whether that's both even or both odd. So we can't make this alternating parity all the way through. So yeah, it's quite tricky to see. You could also argue that because C is the highest, C must be referring to this 6, so C would be 2 mod 4. And then the next one down is also 2 mod 4, so that would have to be the 2 over here because we're alternating parity, which gives us the digit 2 here. There's no other way of making this 2 work. And then B is the lowest, which would have to be a 1. And so these 2 digits would sum to 1. So there's a couple of different ways of making this break, but the point is we can't make this row work unless the grid intersects with it. Hopefully that's not a completely unreasonable step. I will agree it's difficult, but I think it's certainly a reasonable question to ask at this stage in the puzzle. So we can now grey out all of this, because that won't have any grid in it. Okay, now let's ask about BCC again. Just trying to remember the next step. We now know that B plus C equals 0 mod 4, because we now know that in this row we're going to see the digits 1, 2 and 3 within the grid, and internal Japanese sums clues that sum to 6, 1 plus 2 plus 3. So altogether this will sum to 12, so B plus C sums to 12. How can we make that work unless B is even? We can't, because C plus C, C mod 4 plus C mod 4 will be an even number mod 4, and therefore B needs to be even as well to keep the even parity for when we want to arrive at 0 mod 4. So B must be an even number, and actually we know it must be 2. Because if we tried to make B a 4, given that this is the lowest of this string of numbers, even if we made it as low as possible, 4 plus 5 plus 5, that sums to 14, and 14 is too much, it's higher than 12. So B actually is 2 now, in this case, or more generally, B is 2 mod 4. That's what B is representing. And therefore, by elimination, given that we said earlier that A had to be even, A must be 0 mod 4. So that means C must be an odd number, either 1 mod 4 or 3 mod 4. Obviously, we don't have any Ds in this puzzle. We don't actually require any Ds to solve this puzzle. The Cs are enough. But yes, we don't yet know whether C is representing 1 mod 4 or 3 mod 4. Okay, now this string of digits is interesting because these are now completely inactive. They are out of the puzzle. They cannot be where Japanese sums clues go because they are not in an orthogonal direction away from the grid. So these 3 cells must be a string of even digits summing to a mod 4 and or odd digits summing to a mod 4 and then same kind of thing with b. That tells us that this must be odd because we must have an even number of odd digits if we want to sum to an even total, and we know that A and B are both even. So this is an odd digit. Let's come back to this row, because we said, didn't we, that B is even. In fact, we specifically said that in this row B is representing 2. Well, we actually know that there will be a 2 in this row. I feel like I'm going back and forwards between different points here, so apologies for that, but I think these are all very reasonable deductions to find. There is a 2 in this row, and that is a string of even digits. Well, 1 even digit. And so that must be what the B is referring to, because in order to get odd totals, and we know that C is an odd total here, we must have strings of odd digits. We can't have a string of even digits summing to an odd total. So we must have something like odd, even, odd. And the even digit that we have in this row, the only even digit, is the B, which is a 2. And we can't have any more even digits or even clues or even anything in this row. And given that this can't be where the grid goes, it must be an odd number. Which means that this must be even. Alright, A is 0 mod 4, we've established this already, and this is the smaller of the 2 clues. So A must be at least 4, A can't be 0, even though it's 0 mod 4. These are all positive integers that these letters are representing. So A is going to be at least a 4, which means B must be at least 6. It can't be 2 because these are written in ascending order. So can this be the B? Well, if it was, it would be a 6. And the only way to make a Japanese sums clue that's a 6 would be if we had a horizontal stripe of a region. But we've already established right at the beginning of this solve that we cannot have any horizontal stripes in our 3x3 regions. So this is not the 6, it must be the 4, which is the A, and that must be the sum. Those must sum to at least 6, possibly 10, although 10 seems a little bit unlikely, but we'll come back to that. Right, now let's look at this AA clue, because we've got a 4 now. We've only got 2 clues here, so we must have 1 string of even digits and 1 string of odd digits. And we actually know now that the odd digits that must appear in the grid, 1 and 3, they must be the only odd digits that we get, because they don't kind of echo as Japanese sums clues outside the grid. Let's say if we had region borders here and a 3 here, we might also get a 3 over here, but we don't get that because this 4 can only be made up of the 1 plus the 3 within the grid. So 1 and 3 are our only odd numbers. They must appear to the right of our string of even numbers, so we can't have any more even numbers to the right of our string of odd numbers, otherwise we would expect 3 clues over here. So we have a 1 and a 3, a 1-3 pair at the rightmost end of this row in terms of the active cells. Can it be over here? And the answer is no, because then the grid would be this area, we would expect a 2 here, and then, well, that 4 would be in the wrong place. It would be detached from the grid. We need the 2 to be on the left of the 4 clue, so we would be putting the 2 clue over here, and there would be an empty cell here, and that doesn't work. So actually, we've now found where the grid is. That is this 4 clue, and we can't have any more even digits to the right, so this is a 2 within the grid. We now know where the grid is. It's here. So let's corner off those as inactive cells as well. We also know that this is a region border, and these two are part of the same region because they're being referred to by this 4. We said we needed a vertical stripe region, and that must be here now. That's the only place it can go. And so this is a 4 clue, this just is a 2 clue. That doesn't really tell us anything, but we can fill that in. That's referring to this, and this is just an inactive cell. There's nothing to go in there. Alright, so the next step. Well, this is all 1-3. We said right at the beginning that if we had a horizontal stripe region, then we would have 3 regions in the middle column. Exactly the same thing applies, but with the middle row, now that we've got a vertical stripe region, because whether yellow pokes up here or up here, the third region will be whichever one of these is not yellow. So we are expecting all 3 of these to be active Japanese sums clues. So this must be referring to that one, and it's an odd number, so it's a 1 or 3. This must also be an odd number, and this must be where the 2 goes in the region, and these are all going to be region borders. This is going to be a 1-3 pair, representing those 2. And then these 2 must be in the same region as well, and we just don't know which one. In fact, we do know which one is purple and which one is yellow, because yellow needs a 2, doesn't it? So that is where yellow goes, and we can finish off our regions. Very nice. That must be where the 2 goes. And now let's finally look back at this row. If we made this an active Japanese sums clue, it would be an odd number, and it would be forming part of our string of odd numbers over here on the right hand side of the row. However, odd plus odd equals even, so we would be expecting to see an even total over here, but C is an odd total, so we can't make this an active Japanese sums clue. We must instead make these 2 our active Japanese sums clues, both of which are odd. One is referring to this digit, and this one is referring to the sum of those 2 digits. Now this is where the ordering comes in, because we're told that B is the lowest clue in this row, and B is the 2. This one, therefore, has to be higher than 2. It's represented by this clue here, this C, which is higher than 2. So, therefore, it must be the 3, and that disambiguates absolutely everything. We get the 1 and the 3 sorted out, 3 and 1. This is now a 5 because it's 2 plus 3. This is a 1 because it's 1. That all gets resolved. And we can see that 1 plus 5 plus 1 is 7, which is 3 mod 4, and 3 is also 3 mod 4, so these C clues are correct. 5 plus 1 is 6, which is indeed 2 mod 4, so the B is correct. 2 plus 4 plus 2 is 8, which is 0 mod 4, and 3 plus 1 is 4, which is also 0 mod 4, so everything's working out, and we can just fill in a 6 here as our Japanese sums clue for this column, and then 3s in all of those places to finish the puzzle. This puzzle was originally made kind of as a joke submission to Scojo's prompt asking for snack puzzles. Relative to this puzzle, by the way, this is only the example puzzle. This is the actual puzzle that the bookworm published. Japanese sums number 2. There's even a number 1. So relative to this, I do strongly believe that this counts as a snack, but perhaps seeing this solution guide, um, you will disagree. And snack is perhaps not the right word for this puzzle. Anyway, thank you very much for watching. I hope you all have a lovely rest of your day, and I will see you again soon.